I'm old and forget a lot, so I depend on members to remind me what I'm supposed to do. So I put together this thing, and it's mainly photographs, but you might enjoy some of the photographs. Oh, wait a minute. Come on. There's nothing more wonderful than to be in this position, to have an absolutely deep blue sky. The sun has set. You're getting ready for night, for observing, and the sky is absolutely clear, and thinking about all the things that you can see in the night sky. So the first thing we like to look at is the moon. The interesting thing about the moon is we look up at it when it's full, or even when it's first quarter, which is the half moon, and it looks smooth. It looks like it probably has the relief of a 25-cent piece. You know, it looks absolutely smooth. Maybe there must be something there with a little texture. But it's an astounding thing to see through a telescope. I'll come back to this and talk about some of the things that we like to look at on the moon. So this is a thing that I do at the telescope out in the dark with my flashlight. This is what an object looks like the full moon when it's lit. If I hold a flashlight over my head and hold my hand up like this, it's very flat lighting. But the time that's spectacular is first quarter moon, and that's when the sun is setting here, the moon is there, and the light is raking across the surface. So you can see this looks relatively smooth, and this shows every sort of ragged detail of the moon. So this is a first quarter moon, and you'll notice from top to bottom, it's crater after crater after crater. They run into one another. It's just a string from top to bottom. And the story is the surface of the moon is smashed to pieces. I mean, I was going to say there isn't a smooth part on the moon, but I'm going to talk about Mare, so there actually is. But it's unimaginable that this thing could be so smashed and battered, and I'm going to explain why that happened. Here's a closer view. This crater's, you know, one crater is formed by something hitting it and another one right next to it, and some craters have other craters inside them. It is an absolutely spectacular thing to see. What's interesting, I don't know. Yeah, I guess you can see the cursor. This area looks really ragged, and over here it looks much smoother. But in fact, this area has just the same number of craters, but the light is more frontal, and so it doesn't look as ragged as this area over here. The next day, the next evening, this area will look like the smooth area, and there'll be more ragged craters over there. So this is an artist's concept showing a very young star, like our sun, encircled by a disk of gas and dust, the raw materials from which rocky planets, such as Earth, are thought to form. So it's a giant ring with a star in the center, and gradually there are discontinuities, like here and here, where there's a little more material in this disk, and so that has its own gravity, and it pulls a lot of the dust toward itself. And the bigger it gets, the more gravity, the more material it puts in. And you can see there's a bunch of these things starting to form, and that's how the planets form. They accrete all this material, and as they sweep around the star, they kind of clear their path. It's like something sticky, you know, it just goes around and picks up everything that's anywhere near it. But there's a lot of junk going around that star. So the latest sense is that the moon formed when an object, maybe half the size of the Earth, smashed into it in the early solar system. There were things sort of going every which way and blew out all this material, which you can see coming out from the impact. But Earth's gravity was strong enough so that material which was blown out in this collision was captured by Earth and went around Earth and gradually coalesced into what we know as the moon, and it stayed captured. And when all this material was molten, it came together. Because it was molten, it was able, gravity made it form into a sphere, and that's where our moon came from. But don't forget all the junk that was here, left over from the solar system. And as all the planets went around, they attracted all this dirt, rocks, whatever, and the moon attracted that too. And that's what pummeled the moon and made it, it was like a vacuum cleaner going around, and wherever it went, it pulled this junk in, and whenever the junk hit, you got more craters. This is a photograph of Meteor Crater in Arizona. So Earth had a lot of craters as well as the moon did. However, what's different about us is we have an atmosphere. So a lot of smaller pieces were burned up before they got to Earth. But Earth had a lot of craters, some of which we're still discovering. But heating and cooling, freezing, thawing would break down things, the Earth, and gradually, sort of over millions of years, the craters would sort of fill in, trees would grow on them. I think they were still finding craters by radar up in Canada. So Earth had a lot of those, but the small ones just disappeared from weathering over the years. This is cool. I'd never seen this before. It's a satellite photograph of Meteor Crater. If you're ever out in Arizona, it's worth a visit. There's a visitor center. You don't go down into it. One of the things that's interesting, this is called the Barringer Meteor Crater, and I'm not sure of the history exactly, but a guy named Barringer owned it. I don't know whether it was on his land or whether he bought it from somebody, but his sense was that a giant a monstrous chunk of metal made this and smashed into the Earth and blew out all this materia. It's called ejecta. And he felt that the metal would be buried at the bottom of the crater. And I don't know how many years, it was probably 20 years he was in there excavating, because if he found a big chunk of nickel, it would be worth a fortune. And he never did. And later on, they figured that whatever did this was also vaporized in the explosion. But then he had a tourist attraction, so it wasn't all bad.
He
There
died.
are smooth areas. Was there a question?
Yeah, I was going to say, this is George. He died of sadness, or whatever you call it, that he couldn't find that. He was a really disappointed man. He bought the crater, he bought the area. He recognized that crater as not being volcanic. So he did some, research on his own on that. It's an interesting place to visit, by the way, if you ever go to Arizona.
I'm sorry, what was the last thing, George?
It's an interesting place to visit if you go
Oh,
to Arizona.
yeah, it's really spectacular. So he died of sadness, George said, because he never did find the mother lode.
And much in debt.
So the full moon is a little less interesting because we don't see that ruggedness, but instead we see what are called lunar mare, and those are these dark areas, and they call them mare, which is Latin for sea or ocean, because before telescopes, if it's dark, it was probably big bodies of water. And it turned out they're not. They're lava flows. I always thought that there was a big crater and then another large object came in and punched a hole in the center of the crater. The earth was molten and the lava flowed up. It was like an eggshell being cracked, and the lava flowed up and filled in the large crater. But recently I read that it's impacts on the back side of the earth that caused the lava to flow out on this side and create these seas. And they are as smooth as silk, as rugged as the mountains are, the mountain ranges and the craters. These things are so unbelievably smooth, and you can see them in a relatively low power telescope. It's an amazing contrast. One of the things that you can see pretty much only at full moon are these things called crater rays. And this is Tycho down here, and it doesn't show as well as it does on my computer, but some of these crater rays, here's one, go out 2,000 kilometers. One of the crater rays went over, was where Apollo 17 landed, but these go for hundreds of miles. You know, when something hit, it went up into the air, except there wasn't any air. It left the surface, and so there's no friction, air friction holding it back, and they went out to some amazing distances. So this is Tycho, and this is, what is it, Kepler? Copernicus, and then Kepler is over here. There are three of the big ones. But it looks pretty much like what it would look like if you dropped a watermelon off a skyscraper. I'm not sure how many of you were David Letterman fans, but that was one of the things he did.
So Ken,
Yes,
are those dust and debris trails?
that's their debris trails, yeah. And there's something about the nature of the material. Actually, this is good. It gives a better sense of it, that it reflects the light when the light is direct. Like my hand when the light was coming over my shoulder. A few days before or after, everything changes and those rays are not obvious. Oh, and there's Copernicus and Kepler. They're pretty amazing things to look at, but nothing compares to the first quarter view of the moon with those ragged craters. So one of the other things we look at is the planets. I did not do this with my telescope. This is a Hubble picture. And you can see all kinds of subtle things. Here's the shadow, the shadow of the rings on the planet itself. And of course, we don't begin to see this much through our telescopes. Saturn tilts over, Frank, what's the period of time from 22 years or something? Yeah. How many years? 30 years. So it may start out down here, and then it does this. And one of the cool things, which is coming up, is the rings will be edge on at one point that we're headed to. I've seen it once already, and it's astounding because they almost disappear. They're so thin. So this is actually too big, but if you're in the back row, that's probably, you're probably seeing more than we see with our telescopes. Maybe that should be half that size. And that's what Saturn looks like. And even though we don't see that detail, the minute you look in and see those rings, somebody told me a story recently when they looked into a telescope for the first time and said, that has to be something you put in the telescope. They couldn't conceive that if you used a telescope, you could see this. I thought that was amazing. And then one of the things that we don't see on Long Island, but is a wonderful thing, is the Milky Way. So this is from a trip that I took with some friends to Big Bend, Texas, and take a good look, because unless you go there or Arizona or New Mexico, thanks to light pollution everywhere. This is the Milky Way, and it's absolutely magical in all the objects that are in it. It is a wonderful thing to see in a dark sky. You don't need a telescope. You just stand and tilt your head back, and then your jaw drops because it's so beautiful and so subtle. Oh, and I have to throw this in. If you go on, where do you go? If you search for Milky Way in Google, this is what the Milky Way looks like. I didn't do anything to this picture. You will see Milky Ways that look like the sky is on fire. And that's people that put this into Photoshop and then crank up saturation and contrast. And it absolutely makes me crazy because the Milky Way does not look like that. But when somebody learns to photograph it, they look around. Just do a Google search for Milky Way and you will be, I love this, shocked and saddened. And what happens is somebody shoots a Milky Way like this and say, well, that isn't interesting compared to what I see on Instagram or whatever. And it makes me nuts because whenever these things are sort of cooked or overdone or oversaturated, when somebody comes out and looks at the real Milky Way, they say, well, that doesn't look like anything because they've seen too many of the other pictures. This is the Milky Way in Springfield, Vermont, where Stellafane is. You can see that it's a little less distinct, but it's still pretty good looking. And then this is the Milky Way on a good night out east. I think I did this in the Hamptons. I look like I'm in a parking lot, but it has, light pollution. There's still some pretty good definition, so I don't know when it was. And then a lot of us used to go to Custer Institute to observe because it was dark skies, but that back then Route 58 was sort of a sleepy 2-lane road, and now it's 4 lanes with big box stores. And I used to always think you could see the Milky Way on a good night from Custer, and after who knows how long, 6 years of going out and not seeing it and thinking, oh, it's just probably a bad night. Some of the members discovered a little boat ramp out in Orient. And so this is an improvement over Custer Institute. But so it's about the best we can do on Long Island. So a lot of people go out to this little dirt parking lot in Orient, and it's a joy to see the sky from there. This is up at a place called North South Lake. I used to get a kick out of this name. Some friends in the AAA in the city go up there. It's like North South Lake. Which is it, north or south? Anyhow, and I can't remember the name of this town, but it's 15 miles away and it's not a big town. But under a dark sky, you can see that it's, it takes out the first 10 or 15 degrees. And I didn't do a good job with this. The stars are out of focus, so there's less definition than there should be. And this is from Robert Moses on a really bad night. You can see hints of it coming up here. So light pollution is really killing us. The other thing that we can't wait to see, but we wait forever and nothing ever happens, are comets. And everybody's saying, it's about time, it's about time. In 1970, my wife and our kids went home to my home in Milford, Connecticut. And this was Comet Bennett in March of 1970. I'd always been interested in astronomy. I took one course in college, but that was it. I'd never done any observing. I thought you need to own a telescope. And I read that this comet was going to be up, and they said the time to see it was at 3 o'clock in the morning. And so you can see that obviously that's zooming through the sky, right? So I made sure to get up at 2:30 and went out and got our old pear tree in the picture to the right and the TV antenna. And I went out maybe 2:45 because it was obviously going to come zooming through at 2:45 at 3 o'clock. And I was stunned. I mean, first of all, it's beautiful, but it wasn't moving. And I thought I was going to go out and at 3 o'clock, it would go through the sky and that would be it. And I didn't want to miss it. So obviously I had no idea how comets behave, but that's my Leica with a 35mm lens and black and white film. And I kind of treasure that. That was my first astro photograph. This, however, is an astounding comet. And I should probably tell this differently. So this is comet Hale-Bopp, and it was discovered in July of 1995. It became naked eye in May of 96, and we were waiting and waiting and waiting for Hale-Bopp to come. It was a long way out, and it stayed away from us, and it finally, I'll stop there. So we're waiting for it. Around March or April of 1987, in March of 96, a very fast moving comet came out of nowhere, really close to the Earth, moving fast, and it was comet Hyakutake. And its closest passage was March of 96. I mean, that's astounding. I think that's a 35mm lens. There were reports in Arizona from Kitt Peak and the other places where the comet and the tail subtended 90 degrees under dark skies, which is, and look at this for Long Island. You can see the light pollution in the sky. And this was from out, we had gone to some Boy Scout camp, I think, which was supposed to be darker than Custer. But what a magnificent object that is. And while everybody's waiting for Hale-Bopp, this comes through. There were like a couple of nights to see it, and then it was gone. And so finally, Hale-Bopp arrived March or April of 97. And I'll show you with the cursor. Notice there's two tails, and the blue gas tail, which is here, points directly away from the sun. And this is the dust tail. It's a little hard to see, but the dust tail curves because it's following the orbit. The comet is leaving that behind, but the comet is in a curved orbit. So, I mean, Hale-Bopp was spectacular, but Hyakutake stole its thunder for a bit there. So deep sky objects, when this is in the sky, this is the double cluster, and it's best seen from a dark sky. I can see it from my side yard in Seacliff, and this is like diamonds on black velvet, like electric diamonds in a dark sky. And from Seacliff, it's sort of a light gray dot on a dark gray background, and it's kind of nothing to look at. But when you're in a dark sky site, for me, it's the first thing I look at in the evening when it's up in the summer, and it's the last thing I look at before I head home. One of the things I discovered, instead of, because I'm always showing things to people, I would put this in the eyepiece and say, hey, take a look at this. And people would go, wow. And then I got an idea from someone. So you can see the cursor, and there's fewer stars over here, right? So what I do is I make this the field of view over here where there's not much going on. And I say, look in there, and they say, you know, there's some stars, okay. And then I say, I use Dobsonians. I said, just push it a little bit to the right, and the whole group of stars comes into the eyepiece, and it knocks your socks off. It's a wonderful way to show that to people because it's spectacular by itself. But when you realize what it is compared to the nearby sky, which has a bunch of stars, but not that many. This is Messier 13, which is a globular cluster, and it's one of the brightest in the sky. It's higher in the sky than, for instance, another globular, M22. And this is made up of, I think it's 300,000 stars or maybe 500,000. So for those of you who haven't heard about this, it's when you look at it with the unaided eye, it's a ball of stars. And it's like, wow, that's a lot of stars. And then you start thinking, I wonder if they all smash into each other. And when you look at it into an eyepiece or look at this photograph, it's like, come on, clearly they're all smashing into one another. They have to be, they're so close. And the answer is, are they smashing into each other? And the answer is no. And it's like, why not? And it's because there's a lot of space between them. And it's like, what? A lot of space? Are you kidding? But they're all in orbit around each other, and generally they don't smash into one another. So it's a pretty spectacular sight. And a photograph tends to show more of them, but to look in the eyepiece, it's a wonderful thing. They think that there was enough material here to make a lot of stars, 300 or 500,000. So it made a big ball of stars, but it wasn't enough stars to make a galaxy. I believe that's current thought, that they're not quite enough for a galaxy. This is another thing called the Ring Nebula. This is a photograph that I did. And there are spectacular photographs of this if you look up the Ring Nebula on Wikipedia. But this isn't bad for a quick little photograph. When some stars of a certain size reach old age, they collapse and then explode and blow off a ring of material that expands. And John Vogt has a telescope with a 32-inch mirror, and under really good conditions, you can see a little dot in there, which is the leftover star from this ring. And the ring is a sphere, equal gas all the way around, expanding it. So we're looking through a thin layer of it, but the sides of the sphere are what make this donut shape. When you look at this through a telescope, it's faint enough that we do not see the color with our own eyes, but still it's semi-impressive to see this smoke ring in the sky. And this is our sister galaxy, Andromeda. From a dark sky, you can see this smudge with your naked eye, and in binoculars, it begins to look pretty amazing. And under dark skies with a telescope, it's just astounding. There are actually 3 galaxies here. This is the main one, and then this is a small sister galaxy, and I'm not sure. I think the other one is yeah. Oh, that one? Oh, yeah, okay, good. So that's a pretty cool thing to see. Every year when we go to Stellafane, I always make sure I look at Andromeda, because it's the same size as ours. It's headed our way. We're going to collide, and they're not sure what happens. But there's a curious thing that happens if 2 galaxies come together. Like, not every star hits another star, once again, because of the space between them. So they kind of pass through each other, and then the gravity swirls them around and they come out the other side, and it's an astounding thing. This is a very bad photograph that I did because I didn't know what I was doing. This is the Great Nebula in Orion. I was trying to learn how to use this new camera and couldn't figure it out, but I was stunned that I could get this. This is a star-forming region. You've probably heard of Orion the hunter, and he has a belt of 3 stars, and he has a sword of 3 stars. And this is the central star. This brightness is the central star of that sword. And this area is a star-forming region. And in a telescope, you can see 4 or 6 stars that have formed. This is one of the most magnificent things you can see in a telescope. Once again, you don't see it with color because it's faint, but as a gray thing that you look at in a dark sky, you see these wings coming out. It's like some kind of goldfish, and there's this open mouth. It's one of the first things that we love to look at. So the other thing we love when they happen are eclipses and transits. This is a total eclipse of the moon. Once again, it's a photograph. So when the moon is eclipsed, it moves into Earth's shadow. This is barely visible to the naked eye, depending on the season. Do we have smoke in the air? So this is a very faint object without any color. But when you do an exposure, which might be 1 second long, and the film records that faint object, the moon is orange because it's in the shadow of the Earth. Here's another view. And the thing that's cool about this is you never see the moon and stars around it because it's so bright that it washes out these stars. So that was the cool thing, is when you get the moon and you get a few extra stars in the field. There was a partial eclipse of the sun that happened in sometime June of, oh man, when did we have that partial eclipse? June 10th, right? No, I don't know. Anyhow, April 8th. Thank you. Okay, so this is a partial eclipse. I promise you I wrote it down.
I think that was October or sometime.
No, it was nice weather. Okay, so the deal was the moon had been covered by the sun, and the eclipse, it had happened, you would see it from England, but when it rose here 5 hours later, the moon had started moving off the sun. In a partial eclipse, there's liable to be a ring around it or a big bite taken out of it. So the idea was a number of us from Astley went up to Bayville and were waiting for the partially eclipsed sun to rise out of the water. And what made us nervous were these clouds on the horizon, because, you know, if they're on the horizon, they're harder to see through. And we crossed our fingers, and that's what the partially eclipsed sun looked like coming out of the ocean. And notice the heavier clouds here. So it was visible like this, you know, for a few minutes off and on, but, you know, we were lucky and we got some great shots. You know, I can't remember. I think it was that faint. Yeah, right. This was a 4-inch f6.5, so it was about 700 millimeter. And I think I might have put a 2X Barlow on it. Anyhow, this is the same place in Bayville, and there was wrote this down. So there are transits of Venus, and you get 2 in 8 years, and then nothing for about 125 years. So it's possible to live without having seen a transit of Venus, unless you're over one of them, maybe it's 105. But we were lucky, And in June 8, 2024, there was a transit of Venus. And I went to Bayville because it was close by. And some people went to where? John, where were you? You were on a beach, way east?
I don't exactly remember, but I actually think it was 2004.
Oh, yeah, I'm sorry, June 8, 2004, right. So a bunch of people were there, and it was cloudy from the water up about 20 degrees. And I thought, oh no, because the transit had been going on, starting in Europe, and it was Venus moving in front of the sun. And it's rare because that Venus all the time goes above it, below it, above it, below it, but rarely does it cross it. So I get there and it's all cloudy. This must have been the transit of Mercury, but you can see the equipment that I was using. So I get there and it's cloudy up to 20 degrees. And I thought, well, I'm going to sit there and I'm going to wait and we'll see what happens. And after a while, there were some breaks in the clouds. And at one point, there was like a clear break, and I was watching, and I could see the curve of the sun. It was like a little slit in the clouds. And so I watched the round part move into the slit. And it's only, if the sun is that big around, the slit was like that big. And it's like, okay, here it goes. And it goes by and it's getting bigger and bigger and bigger and further up and further up. And I'm waiting. And then all of a sudden, here comes the slit and here's a black dot. And it's like, oh, I've seen it. And then I keep watching because I'm there. Why not wait? Bang. I mean, that looks like the dawn of creation. And what's interesting is I was so lucky because most people, where the weather was clear, got a white disk in a blue sky with a black dot. And this was so much more than that. I think this ran on page 1 of Newsday. I was a photographer for Newsday my whole life. The interest in this is that Venus is slightly smaller than the Earth. So what we have here is sort of a reference of how small the Earth is. And that's the magnificence of this. But I was so lucky. 8 years, wait a minute, got to do this right. 8 years later, that was June 8, 2004. June 5th, 2012, there was another one, and I set up in Seacliff, and it was late in the day, and it was completely cloudy. We could sort of vaguely tell where it was, and I set up my telescope in the general area of where it was, and the sun was sort of setting. I forgot how high it was. And then suddenly we could see it. And I started shooting. It still has some clouds in front of it, and you can see sunspots on the sun. And I'm just going ka-chink, 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 ka-chink. And a couple people wanted to look, and they got their look, and the clouds moved in, and boom, and that was it. I later learned that hundreds of people went to the South Shore to Jones Beach, and they watched the entire thing, in a clear sky. So it's really a turkey shoot, but I'm thrilled to say I was one of a bunch of people who has seen 2 Venus transits in my life. So anybody want to guess what's interesting in this picture? Yeah. So down in the lower left-hand corner is the planet Mercury. And this was photographed from Bayville again. That's probably where that other picture came from. And transits of Mercury, the last 4 were in 2003, 2006, 2016 and 2019. So they're far more common. That's just after it crossed the limb. And here it is a little further out. And this is like really cool because, you know, how big is Mercury? Well, it's smaller than Earth. Well, you know, what's small? I don't know. And a transit like this, when we get to see Venus and Mercury, you suddenly realize, wow, they're really small. We're small. Stars in the landscape. I went out to with a friend to visit a friend who was a professional astronomer and lives in Magdalena, New Mexico. And he knew somebody who was at the Very Large Array. And my friend Stan Honda and I asked him if he could ask somebody there, because it's a radio telescope, the giant radio telescope. And we were concerned with our digital cameras, if we went out to photograph, would there be emissions from our camera that could be a problem for these dishes? Our sense was probably not, but you know, who wants to ruin a radio astronomer's evening? So John called somebody and they said, no, we'd be fine because we were to the side of the dish and it's focused. So we drove down this road, and this was one of my favorite pictures because of this. And this is called the zodiacal light, and it's incredibly fine dust particles in the plane of the ecliptic, I guess. And at certain times of year, the sun, which has set, illuminates these fine particles, but you have to be in a jet black sky to see this. And this was almost as bright as the Milky Way when that came up. But to see the zodiacal light, that was only 5 or 6 years ago. And of course, having a giant radio dish. There's a whole bunch of these dishes. Here's one, here's one, here's one, here's one, here's one. They're on railroad tracks and they move them around in a Y, and the dishes get further apart or close together.
You
This
can't. In
Chaco
that
Canyon,
picture,
which
you
was
also
built
have
by
the
the
Andromeda
ancient-
galaxy.
I'm sorry, say again?
In that picture, if you go back, you also have the Andromeda galaxy.
Is that right?
Yeah, up to right.
Get
upper.
out. Nice going, George. Holy cow.
Whoa.
I know the sky like the back of my hand. Thank you. Wow. So this is Chaco Canyon, and they now, the Native American peoples prefer the people who built this and lived here, the ancient ones. They used to be called the Anasazi. This Chaco Canyon is an astounding thing. It's 3 hours from Albuquerque. And there's no place to stay unless you camp. And I'd been there before, but just during the day. So Stan and I, a couple other friends, went out and stayed there for a week. It was actually for a partial eclipse, a perfect ring eclipse. And this is the Great Kiva. And they think these were places of worship that were at one point covered. So I got the idea from other photographs that I'd seen. And the first thing I did after I landed was buy a 5-cell mag light. And then this is a 1-minute exposure, which captures the stars and a little light on the horizon. And these are a little bit blurred, but I ran around out of the picture here and shone my flashlight back and forth against these areas and lit them up. So I would do a photograph, it was digital, run back, Stan would open the shutter, then close the shutter. I'd run back, look at it, more flashlight here, less there. And this ended up being a fairly spectacular picture of these ancient ruins. Look up, it's actually Chaco Culture Center, but it is astounding, the structure and the beauty and the accuracy of the architecture here, the things that they built. And then at some point, it was sort of a central trading area for the ancient ones, came from all directions, and they've seen photographs, aerial photographs that show paths in the desert that go off to these areas where people would come together. And then something happened, whether it was food or they cut down all the trees and burned all the wood, and they couldn't stay there anymore, and they just disappeared, and they left pots and things. It's an astounding place to see. This is John's 32-inch telescope at Stellafane. It's so tall, you can see the person is on a stepladder looking through the eyepiece. So that's in Vermont, and that's Jupiter behind. And it's a really dark sky sight, but notice the encroaching light over here. John's telescope is beyond astounding because it collects so much light, and we can see things faintly in our telescopes, and in John's you see things in great detail. This is a photograph by my friend Stan Honda, and I forgot the name of this, but it's an abandoned fort up in northern New Mexico, and I wrote it down somewhere. And what? No. Yeah, I'm sorry. But anyhow, it is now a national park. And these are the adobe, chimneys and things. And Stan went up. He is an artist in residence from time to time, where he can go and stay there. And they give him board, a room, and then he photographs. And he has to give a couple of talks during his 2-week stay. But look at Orion and how clear that is, Orion's belt, the belt and Orion's sword. And just for fun, here's how clear it is. And notice that smudge, that's the Orion Nebula. Yes? I can guess that it's northwest, and I'm sorry.
It's really flat.
Yeah, right.
Please, at the top of the frame before George points it out.
There's the Pleiades. Yeah, I'm really observant. I'm a good observer. And after having seen Orion from here, this is Orion from my backyard or from here at Vanderbilt. And notice how it's a little blurry. Like these stars are sharp, but this is a black sky. And a friend of mine who's in the AAA in the city suggested you buy a fog filter, or kind of filter that you use to do portraits to sort of soften things, a diffusion filter, but it's a fairly light diffusion filter. And what happens is you use it for part of the exposure. And you'll notice there's a sharp star in the center of each of these little fuzz balls. And if I photograph, I don't think I did one without it. Well, no. So you would see the stars, but the constellation doesn't stand out quite as well as if you use the diffusion filter for maybe 1/4 or 1/2 the time, and you get the sharp star and a little fuzz ball, and the constellation kind of jumps out of the sky at you. And here's Orion from my backyard with a little bit of diffusion filter. And for Daniel, this is my tribander down here. We were talking, Daniel is visiting us, and he's just got his Mars. And it's so overexposed, it's not orange, but we were talking about ham radio, and there's, oops, sorry. That's my tribander, which I recently took down. This is from Custer Institute. This is sort of, fun to photograph some of the constellation, not Custer, it's from Vanderbilt, I'm sorry. Cygnus the Swan, And you can see, you know, we can get some stuff with the brighter stars, and Vega. But there's a lot of light in the sky, and I used a diffusion filter here for the same reason. And then the moon and the landscape. The moon is a lot of fun to photograph close, but in the landscape, it's kind of fun. This is not the world's most beautiful picture with the telephone pole, but I couldn't get around it. So when the moon is crescent, you can see this with the naked eye. Let's pretend I'm the Earth, and let me do this right. And the moon is the garbage can, and the sun has set over there, and it's only a crescent moon, so only a little bit of it is lit, but the whole back of the Earth is lit. And so the light reflects from the Earth toward the garbage can, and that's called Earthshine. And we can see not only the crescent, but we can see the dark side of the moon. And that's a very cool thing when you get to see that. This is just my house, part of my house, and the moon. And I think that's Venus, just over the chimney of the neighbor's house. And this is the moon again with Earthshine and Venus. It's really fun when you know it's going to be up or a crescent to go out, and the main trick is sort of to find an interesting foreground. And these foregrounds are not all that interesting, but I shoot them anyhow. You can tell this is another from my backyard, moon and Venus. The thing that kills me is that there are these sycamore trees that grow by the water in Seacliff, by Hempstead Harbor. And some of them had died. I've forgotten when I took this, but it was before they were in leaf. And I think this one died. I think these two are alive. They trim them this way. Otherwise, they'd look like normal trees. So these clumps are where they've been trimmed and new stuff comes out. But they make a spectacular foreground, don't they? It's like spooky land. They had to cut this one down because part of it fell down, and it killed me because now there's just an empty space. So here's the cool thing. This is Jupiter and Saturn visible with the moon and Earthshine. This took me several years to do. These are those trees in Seacliff, and I wanted to get the moon rising behind them. And the moon, depending on the time of year, if that's the horizon, or if that's the horizon, the horizon looking east, this month, the full moon, or the day before full moon, rose here. Next month, it's going to be out of the picture there, and then it keeps moving, gets down to here, and then moves back through here and goes up to here. So I have two chances during the year that it's going to rise in that area where those trees are. And there's a narrow area that has the trees. So I went and tried it, and the time was wrong. The moon came up in a different place, even though there's the software that tells you where it'll come up. And then the next time it was there, 6 months later, it was cloudy. And you have to do it one day before full moon, because at full moon, the sun will have set, and I needed some kind of light on those trees. So there's only one day, the day before a full moon, when there's still sunlight, when you can do this, and only twice a year. So I would drive over to Port Washington with a 300 millimeter lens, and finally the third year, I got the photograph. And it's, it's kind of nice. It's hard to know how much work it was. Yes.
Fairly clear.
So this is why It's a good point. The moon's comes up when the moon is full and it rises, the sun has set, so the sky is pretty dark. But the day before full moon, the sun is still up and the sky is lighter. So you can see detail in the sky and the surroundings. So when you want the moon and the landscape, generally you want to be 2 days or 1 day before full moon. The day after full moon, the moon arises and it's in a completely black sky. So if you have any silhouettes of trees or anything, it's all gone. So it's surprising that there's only that 2-day window. And for some things like this, only a 1-day window. It's got to be 1 day before the full moon. Sad to say, as a professional photographer, I set my camera on program mode, which will shock most people. And I push the button and it figures it out. And most times it's right on. And if it's not, there's a little exposure compensator. I'll make it 1 stop darker, 1 stop lighter. So I'm going ka-chunk, 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 quickly. Yeah. And then here's an interesting thing, just from an artistic point of view. Obviously, I started photographing with the first hint of the moon's limb coming above the trees and just kept, ka-chink, 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 ka-chink. And then I got it when it was fully above the trees. And then the question is, which is most interesting? This picture where it's not fully risen, or the picture where it's completely above the trees? And I decided that it was more interesting to have part of the moon still in the trees. But I have one of each if you need that. And then this is the sun, and it has some sunspots on it, and my favorite tree, which is now gone. I mean, how cool is that? If I photograph the sun in the sky, so big deal. It's what is your background, foreground, and the rest. And it broke my heart when that tree finally died, and I don't have, good backgrounds. And this is just a map that I tossed in. It was for 8th graders or something, showing the names of things and all that. So that's the end of my story. Thank you. Let me do this and yes. No, it's lava that's smooth, but it's not like glass, because I'm just making it up. Probably radiation sort of breaks it up or something. But in a telescope, I'm sorry we don't have a telescope and that we could show you that. In a telescope, compared to that battered landscape, one of the astronauts said, magnificent desolation. Compared to that, you're looking with the telescope and you swing it over, and here's this beautiful neutral gray, smooth as can be, with a couple of little craters here or there. So I don't really know the actual surface, but it's not shiny. Dusty. Hang on 1 second. Stop share. Any other questions?
Why was the sun red in the last picture? Does this look smoky?
Yeah, we had terrible fires, as you all remember, last year. The wildfires are in Wyoming and all of those places, Canada, and it drifted over us. And the sun was going down in the west, but it just ruined our observing, because the smoke obscured everything we wanted to look at. But you're correct, that was it.
Still recording, can't. Casey.
Oh, yeah, thank you. I need help with this.
Top left.